All right, so let's do one more example where we have a little bit harder of a rational function. So we'll call this one h of x for the hard function here. I'm not going to choose one that's too nasty, but I'll choose one that demonstrates the basic idea. So we have x squared minus 3x minus 4 over x plus 4. You might notice this gets harder because now we've got an x squared involved. It's not just x divided by x anymore. Okay. Same idea to start though. We know that the vertical asymptote is when we make the denominator equal 0. So we go to -4 and we draw our vertical asymptote. Now, to think about what happens when I plug in big X values is a little more complicated here. Let's say I plug in 1,000,000. The top is 1,000,000 squared and the bottom is 1,000,000. 1,000,000 squared is a lot bigger than 1,000,000. So it seems like as I plug in big numbers, I get really big answers on top and just normal big answers on the bottom. So really big on top, normal big on the bottom. That means that my Y values are getting bigger when I plug in bigger and bigger X values. But we don't know specifically the shape that they're going in because they're not flattening out, so I can't draw a horizontal asymptote anymore. In the earlier video, I got one horizontal asymptote that was 0, that's the x-axis, another horizontal asymptote that's 2. Now it's like, okay, they're getting bigger, but how are they getting bigger? So that's where we use our long division. Okay, so there was a reason, we had you go through all this. You can do the area model, the box method, or you can do the long division. First, I'm just thinking x times what makes x squared? So it's x times x. Then I go x times positive 4. Then I grab this and subtract to see what's left over. Negative 3x minus 4x is negative 7x. Then I do x times negative 7 to get negative 7x. Bring this negative 4 down. Multiply negative 7 through. So negative 7 times x, negative 7 times 4. Grab that, subtract it. The x's cancel. Negative 4 minus negative 28 that's a double negative, so that's a plus 28, so we have 24. So that's my remainder. So what this means is that my h of x can actually be written as, when I divided it, I got x minus 7, but then I had a remainder of 24. That remainder is still part of a fraction. I want you to think about what happens here. What this means is when I plug in really big numbers, this part of it is going to become 0 because 24 divided by a big number gets closer and closer to 0. 24 divided by 1,000,000, 24 divided by 1,000,000,000. But this part of it is a line. When I plug in small numbers, the fraction really matters a lot. 24 divided by 3 that makes a difference. But 24 divided by 1,000,000 is so small that it does not make a difference on the graph anymore. So there's a huge difference between dividing by small numbers and dividing by big numbers. When you divide by really big numbers, it just zeroes out that part of the equation. So the x minus 7, I'll put my y-intercept at 7, and then I count with a slope of 1. Okay, I was pretty close when I just eyeballed it. And I'm going to draw that as a dashed line, because again, this is not what my function is. This is an asymptote. This is what my function is going to get close to. Okay, so now I have my asymptotes drawn. Last thing I'm going to do is find x-intercepts and y-intercepts. Y-intercept is always the same. For any function that you ever encounter in your life, you plug in 0 for x, you get the y-intercept. Sometimes people ask me, how do I find a y-intercept for this type of function? Well, plug in 0. It's always the same idea. The y-intercept is what do you get when you plug in 0? I plugged in 0, I got negative 1. That's my y-intercept. Now, if I set my equation equal to 0, let's do that over here. I'm setting a whole fraction equal to 0, and it looks kind of hard. I know a lot of people don't like fractions. Well, if you don't like fractions, let's get rid of it. How do you get rid of a fraction? You multiply by x plus 4. And if you multiply by x plus 4, it just cancels the fraction, and 0 times x plus 4 is just 0. But now you have a quadratic. So you got to factor that quadratic. A lot of you guys are using the area models. Some people are able to just do it by thinking about the numbers that multiply to make 4, make negative 4, and add to make negative 3. So it turns out to be negative 4 and 1. So my factors, x minus 4, x plus 1. If my factors equal 0, then I just need to solve each factor, 4 minus 4, and negative 1 plus 1. So let's set that up. Here's negative 1. Here's positive 4. It's going to look kind of like an x squared graph through that zone there. It's going to go close to the asymptote over here, and it's going to mirror that down here. And I just want you to mirror it. I don't need you to worry too much about that other branch. So, a little bit harder, right? Let's see how we did. Parentheses around the top. Parentheses around the bottom. All right, I did pretty darn good with my upper branch. And let's clear out the stuff here. I'll type in x equals negative 4. That's the vertical asymptote. Y equals x minus 7. That's the slant asymptote or oblique asymptote. And you can see the other one mirrored it down there. It was a little farther than what I initially drew it, but I had the general shape of it right. Okay. So please let me know if you have any questions or if you want me to do some more examples. Happy to do that. Thank you for watching.